We can now understand that for the production system to run smoothly, some kind of information must be ingrained in the worker machine system. The production system must organize itself to design the processes and equipment, plan and control the production orders, and satisfy product quality requirements. In order to do this, the manufacturing support system, or MFS, must uphold an information processing cycle in which business functions, product design, manufacturing planning, and manufacturing control functions are sequentially conducted. You can see in this diagram that all of these are connected together and how this interact with production system facilities. The beginning and end of the cycle is at business functions. This is the principal means of communicating with customer. This includes sales and marketing, sales forecasting, order entry, cost accounting, and customer billing. If the product is going to be manufactured by customer design, design will be provided by the customer. Otherwise, the company's product design department may be contracted to do the design work for the product, as well as to manufacture it. The departments of the firm that are organized to accomplish product design might include the R&D department, design engineering, and perhaps a prototype shop. The information and documentation that constitute the product design becomes the backbone of manufacturing planning functions. These include process planning, master scheduling, requirements planning, and capacity planning. So process planning determines the sequence of individual processing and assembly operations needed to produce the part. So it is very important in a part of manufacturing planning function that the process planning is done thoroughly. Manufacturing planning also includes logistic issues, which translates into master production schedule. This schedule is a listing of products to be made, the dates of which it must be delivered, and the quantities of each. Based on this schedule, individual components and sub-assemblies must be planned. Raw materials must be purchased, and purchased parts must be ordered from the suppliers. So the whole task is called material requirements planning. Okay, all the raw materials and the purchased parts. This is part of material requirements planning. Furthermore, the master production schedule must be built based on the capacity of the plant. That means the capacity planning must be tallied up with the schedule to ensure the products can be delivered at maximum capacity. Once all of the manufacturing planning are in place, the manufacturing support system must incorporate a manufacturing control over the production system. This concerns the management and control of the physical operations in the factory to implement manufacturing plans. The flow of information we can see in this diagram. It flows back and forth between manufacturing control and factory operations. Manufacturing control consists of the shop floor control, inventory control, product quality control. So the shop floor control deals with problems in monitoring the products as it is being processed, assembled, moved, and inspected. Inventory control attempts to strike a balance between too little inventory and carrying cost of too much inventory. While quality control is to ensure that the quality of the product and its component meet the standards specified by the product designer. So up to now, we have gained some information on how the production system works and how complex the process of managing the production system, because it deals not only with machine and also people, but also inventory and logistics as well. The product quality is also must be considered. Therefore, we can see some potential of automation in production system. The automated elements of the production system can be categorized or can be separated into two categories, which is automation of the manufacturing systems in the factory and computerization of the manufacturing support system. Because automated production systems operated on the factory floor are usually implemented by computer systems and connected to the computerized manufacturing support system, as well as management information system at enterprise level, these two categories can sometimes be overlapped. Okay, the extensive use of computerized system in production basically is given a term of computer integrated manufacturing, okay, which we will see in detail later on. To be honest, automation itself is expensive, but companies who are venturing into automation have some good reasons why they are doing it. Okay, and it can be summarized into two volatile parts of the production system: the worker and the product. Automation is justified to increase labor productivity, which means large production can be carried out with small number of workers. This consequently means we can reduce labor costs, which may lead to reduction of unit product cost. Therefore, furthermore, with small number of workers, the production system can mitigate the effect of labor shortages. Automating a given operation and transferring a worker from active participation into a monitoring role or removing them altogether makes the work safer, in line with the enactment of OSHA, or Occupational Safety and Act. Occupational Safety, Health and Act. Furthermore, repetitive work are boring and fatiguing. Automating such tasks will reduce or eliminate routine manual and clerical tasks. From the product point of view, automation performs manufacturing processes with greater uniformity and conformity to quality specifications than manual work, which certainly improve product quality. By reducing the elapsed time between customer order and product delivery, automation actually reduces manufacturing lead times and may provide a competitive advantage to the manufacturer for future orders. There are also certain operations that cannot be completed without the aid of the machine. Examples include integrated circuit fabrication operations, which sometimes need to be accurate to a micrometer. So, rapid prototyping process based on CAD models and machining complex mathematically defined surfaces that can only be done using computer numerical control or CNC machines. With a variety of good reasons to automate production system, we must be able to approach the current production problems with some strategies for automation. In principle, we call the approach to automation is the USA principle. So U itself stands for understanding the existing process, S, simplify the process, and A, automate the process. Understanding the current production process is inevitable to automation. Okay, what are the inputs, what are the outputs, what exactly happens with the work unit between the input and output, what is the function of the process, how does it add value, what are the operations, and can some of it be combined? By creating some operational charts and flow process charts, we can identify weakness and strength of the production system, the number of steps in the process, the number and placement of inspections, the delays experienced, and time spent in storage can be analyzed to highlight automation that could be in place. Mathematical model relating the input and output can be beneficial, especially in determining what kind of output must be measured for feedback purposes and formulating algorithms for automatic process control. Once we understood the current problem, it is time to simplify the process. This often includes checklists of questions about the existing process. What is the purpose of this step? Is it necessary? Can it be eliminated? Does it use the most appropriate technology? How can it be simplified? Okay, things like that. Now, simplification itself may take or use 10 strategies for automation and process improvement.